All right, student, welcome to this video. The topic is equilibrium. Let's read the question and try to understand what exactly is the query. Okay, let's focus on the question. So this is your rod. Okay, this is your rod. It's a uniform rod. The mass of the rod is 2 kgs. The length of the rod is given to be 1 meters. At the end of the rod, okay, you have a string here. This string is connected to the ball up and is hung. So the ball is in the air now and is connected to a string, right? So we have to decide what's the question? What should be the tension here so that the rod is in equilibrium? What is that we want? We want rod to be in equilibrium. So what does it take for any body? Okay, this is the case of a rigid body, right? It's not a point mass to be in equilibrium. So there are two equilibriums we refer to. Right? So one, of course, is the equilibrium which is your translational equilibrium. Right? So translational equilibrium. Right? We also refer to this as dynamic equilibrium. If the body is in motion, the forces are balanced. It is moving with constant velocity. Okay. So if you notice, this body is in equilibrium. It is not falling down. It is not going up and all that, right? So now the second thing is the rotational equilibrium, right? Which is this body also being subjected to any torque, external torque that also needs to be force taken care of. So the torques are cancelling each other. The up and down force is cancelling each other. The left and right force is cancelling. So the body is in equilibrium. Now, this is the case of a static equilibrium because the body is at rest. Okay. But read about dynamic equilibrium. Go to my playlist. Don't forget to join my community tab. I'm putting thousands of questions out there for your benefit. All right. So you talk about this tension here, and I said this is an equilibrium, right? So if you notice, this rod is uniform, right? So where is the total gravity acting? At the center. So this is your gravity. So the total weight which the body is being subjected to is how much? So this will be 2 into 10 is equal to 20 newtons, right? 20 Newton is the downward force. Okay? There is no mention whether the body is trying to slide down or up. There is no friction here, and therefore we are not talking about this side. We're only talking about this side. Okay. So I hope you're trying to jump to a conclusion. Wait. Now, if you notice, this weight is trying to rotate the body about this axis, which means if you cut the string, the body will come somewhere here, right? The rod is coming down, right? So about this axis, it rotates, right? So it rotates. This is the way it will come down. This because of the torque being provided by gravity. Now the torque being provided by gravity is going to be mg multiplied by. So this is half the length because gravity is acting at center of mass. So we are writing half. Okay. So this is a torque which is a clockwise torque. You can see the clockwise nature, but the body is still in equilibrium. It is not rotating, which means there is an upward torque also being provided by the tension. Tension is providing a counterclockwise torque, which is tension multiplied by L, right? The length, force into force up. Now, this is a situation where the body is in rotational equilibrium also. I will equate these two. So this becomes mg into 1 by 2 is equal to T into L, right? So L is obviously 1 meter. So I'm going to write this as 1 meter, right? So the length is 1 meter. Okay. So this is 20 into 1 by 2 is equal to T, and therefore T is equal to 10 newtons. This is the answer. Okay. A lot of students may be tempted to say that the body is being acted downwards 20 Newton and has an upward force of T should be 20 newtons. Be very careful in the case of rigid bodies. In the case of rigid body, if you find rotational equilibrium situation also, apply that. Just don't restrict yourself to conventional point mass translational equilibrium. The upward force is equal to downward force. This is also being subjected to a torque, right? You need an upward torque to balance that. And therefore, this is the correct approach, not the approach where you put T is equal to directly as 20 Newton and satisfy. That is why I said there could be a friction here which is acting at the axis, and that may be supporting this 20 Newton. So 10 Newton here and 10 Newton here may be supporting the body. Right? But since we were blind about the wall aspects, we just concentrated on the torque aspect of it, which was more predominant in this situation. So I hope this clarifies, this helps you understand how to use torque. You can expect similar questions. These questions are being done to help you build concept, okay? And when you do these questions yourself, all the questions I'm doing will become a key source of conceptual understanding. And go and watch my theory videos also, where I explain the concepts around torque, angular momentum, conservation of angular momentum, so on and so forth. Do not forget to join the community because you will see some outstanding questions being given as practice questions. Thank you very much.